Welcome back to the Bitwise operator. In the last session, we have discussed the Bitwise operator of AND, OR, and XOR. Okay. So we have seen if x equal to 2 bitwise, it is represented like this. Okay. Right. 1, 0, 3 is 1, 1. And you have seen that if you do an AND operation, okay, so 0, 1, it will become 0, and 1, 1, it will become 1. Okay. Yes. And similarly, if you do for an OR operation, 0, 1 will become 1, 1, 1 will become 1. Right. So that will become 3, and this will become 2. Yes. And XOR also, we have seen that 0, 1 is 1, and 1 is 0. So if you do x XOR y, we get 1. Here we got it 2, here we got it 3, and here we got it 1. Okay, so this is clear. Okay, now let us do a shift operation. Okay, so let me remove this, all these things and all. Yes, okay, right. So let us talk about shift operator. The shift operator, there are two types of shift operator. This is called left shift, this is called right shift. And this particular left shift and right shift will be followed by a number. Yes, an integer value which will determine how many type of what is the number of times that the shift need to be done. Okay, so let us remove all these things for a time being, and let us say z is equal to, okay, right shift of, yes, right shift by 1, right, and printf, okay, percentage d comma z. Okay, right. Let us first see the output. This time we'll be discussing in a different way. First, we'll see the output. This is 1. Okay, so when we are shifting by 2, we are get x is equal to 2, we are getting 1. Okay, let us put this as 4, and now let us run this. We got it to be 2. Okay, let us make this as, okay, 8. Okay, saved. We got 4. Let us make this as 16. Okay, save. We got 8. Okay, so let us make this as 100. Yes, we should get 50. So we got 50, right? So typically, if you see anything that we're shifting by 1, okay, the number is becoming half. Yes, now what, how it is happening? Okay, so let us say first take out this to be 2. Okay, and we have this, right, 1, 0. Now when I say shift by 1, means this value will be shifted in 1. Okay, right, this value will be shifted. Okay, right, this value will be shifted to right. Okay, it will move out, and this value will come here. Yes, then this value will come in this place. Okay, so I will remove this. Okay, so this value will come here. Yes, so like way everybody will be shifting, and the value will be coming like this. Yes, the value will be like this. So when you shift, when value of 2, it was 1 here. Okay, now as you do one shift, the 1 has come this side, and all the zeros has been coming in the in the next page itself. So this way the value that we get is simply is 1. That is the reason why when x is equal to 2, we got the value of z is 1. Okay, now let's say x is equal to 8. So this is the value of 8. Yes, this is the value of 8. So now all are 0 here. So if this x is this 1 will be shifted to here, and we know by a by the binary concept. Okay, right. So this is 1, this is 2, this is 4, 2 to the power 2, this is 8, 2 to the power 3, this is 16. Yes or no? Right. Then this is 32. Okay, 64, 128. Yes, Correct? Yes. So this is how it looks like. So this is how it looks like. Yes. So right. So now this one, if you shift from here to there, so it will be shifting from here to here, right? So that means 8 shift of 1, 8 shift by 1, it will make you 4. Yes. Similarly, when I was shifting this value of 16, okay, 16 here it is 1. So it will come down, this 1 will come down to here. Yes. So now it will become 8. Now it will become 8. Yes. Right. Now let us see what is the value of 100. So this will be 1, 62, 96, 1. Okay. 0. Yes. Now what will happen? This 4 will shift to 2. Okay. So we have now here 1. Okay. Now this 0 will shift to 4. So we have here 0. Yes. This 0 will be shifting to here 0. Okay. Now this 1 will be shifted to here. So we have here 1. Right. Yes. Now this one will be shifted to here. So we have 1. Again, this 0 will be shifted to here. So we'll have here 0. Okay. And then this will be 0. Now you see 16, 32 plus 16 is 48. 48 plus 2, it is 50. Right. So now we have seen that if you are shifting this by 1, the entire number is divided by 2. Okay. Right. Now let us see this 100 only. Okay. Again, let us say this again represent this by 100. Okay. And okay, this will be 0, this will be 1, and this will be 0. Okay, great. So this is the value of 100. Now let us do shifting of 2. Right, shifting of 2. If you right shift by 2, that means now 1 will be shifted to this and this. So now 1 will come here. Okay, and this will be okay, 0. Now this one will be shifting 2 times. So 1 and 2. So this will come here. Yes. Okay. Right. And this one will be shifted to 2. Right. 1 and 2. So it will be shifted here. Okay. And now we'll have this 0 and this is 0. Right. So now 16 plus 4 is 24 plus 1 is 25. So that what we need, you should get if you are shifting by this when this is 100. Yes, 25. Right. Yes. Right. And if I do this for 16, if I do this for 16, only 16 value, okay, 1 and shift to, it will come down to here, okay, right? So if I have 16, it should give me 4. So let me say 16. I get 4. So what we are observing, that means if I shift by 1, okay, if I shift by 1, okay, it is dividing by 2. If I shifting right shift by sorry, shifting by 1, it is dividing by 2. If I right shifting by 2, it is dividing by 4. Okay, now similarly, if I right shifting by 3, it may divide by how much? Okay, 8, right? So this way, it is everything that we are shifting it, it has got, it is dividing. Okay, now interesting thing is that if I now use this with y, and I say shift by 1, and this is an odd number. Okay, even number you have seen, all are divisible in that this and all. Now, if it is an odd number, that means value of this 3 is 1, 1 and 1. Okay, let me save. Now, if it is 3, it will give me 1. Okay, see, yes, it is giving me 1. Now, if I say this is 5, 5 means this. Okay, it will give me 2. Just check. Yes, it is giving me 2. Right? Now let us see, this is to be 8, 11. Yes, 11. It should give me 5. It give me 5. Okay, right? So it is not exactly half. Okay, right? But since this particular one bit, which is, which represent nothing but an odd number. See, every odd number will have this particular bit at 1. Okay, and every even number, this bit as 0. Yes, you see, this is the representation of 11. If you say this is the represent of 10. Yes, right? And if I want to represent 12, so this is the representation of 12, right? And if I represent 13, so this will be by representation of 13. So every odd number, last bit is 1. Okay, so whenever having this shifting operator with 1, it is also half, happening to be to half, but it exactly, you should think that it should come up to a 5.5. No, it is not like that, because it is a system of binary in terms of 2. That is the reason why it is coming as 5. Okay, similarly, if you do by shifting by 2, so this is what? This is 11. So now everything will go and it will shift by 2, right? 11, 11 shifting by 2. So this will come here. Yes, this will come here, and 8 value will come here. Okay, and rest all will be become 0. Okay, now the value that we'll get is 3. Yes. Sorry, again let me do it once more. So this is 11, right? This is 11. Now we're shifting by 2. This will 1 and 2. Yes, yes, right? This is 1 and 2. So it will come here. Okay. This will go, this will go. So sorry. So now we'll have this value is like this. Okay. Let me tell it again. Here 1, here 1. Okay. Now this one will go. This one will also go to shift. And this one will come here and here, right? So now we'll be having here, that is 2. Yes. Okay, so I hope this particular right shift is clear. Okay, so in the next video we're going to see the left shift.